We are going to solve an example on material balance. Yes, and the question is a solution composed of 50% ethanol, 10% methanol, and 40% water is fed at the rate of 100 kg per hour into a separator that produces one stream at the rate of 60 kg per hour with a composition of 80% ethanol, 15% methanol, and 5% water. And the second stream of unknown composition. Calculate the composition of the third compound in the unknown stream and have to calculate the composition of the third stream and the compound itself. When carrying out material balance, it's important to take note of the following steps. The steps will be displayed on the screen. The first step is read and understand the question correctly. You read and understand the question correctly. Second step says draw the system and assign the known and the unknown variables. So the second step says draw the system and assign the known and unknown variables. You can draw it using the chemical engineering symbol, or you can use a block diagram. Yes. Then from the question said is a separator. So using a block diagram, this is a separator having an inlet and two outlets. So we denote here as A, B, and C. So the feed, which is A, is having 100 kg per hour, and it contains ethanol, which is 50% ethanol, methanol 10%, and water 40%. For B, it flows at the rate of 60 kg per hour with ethanol, 80%, methanol 15%, and water H2O is 5%. So we are asked to calculate the composition of this and then composition of ethanol, methanol, and water. These are just abbreviations. These are not their chemical formulas, these are just abbreviations. So we are asked to determine their individual composition. The first step is read the question and understand it. Then the second step, draw out the system. It's important to draw out the system so that you know what is going in and what is going out. Understand what you are asked to find. The third step is identify the condition of the system. Identify the condition of the system. From the question, you'll be able to know the condition of the identify the condition of the system. So this system, the condition of the system is a separator and it's a steady state. Secondly, there is no accumulation. No accumulation. And one important thing is that no reaction. And remember, from our general material balance equation, we are dealing with material balance with no reaction. There is no consumer general. So the fourth step is choose a suitable base. It's important to choose a suitable base. So our basis is using 1 hour. So for every 1 hour, 100 kg of the feed was introduced into the separator, 60 kg of B. So what will be the mass of C for every 1 hour? So our hour is 1 hour is our basis. So for the fifth step, step 5, we are expected to use the general material balance. Use the general material balance equation. Now from this we know that it is a material balance with no reaction. So a material balance with no reaction says accumulation is equal to input minus output. So accumulation is equal to 0. This means that input is equal to output. So this is what we'll be working with in this system. First, we are going to carry out the overall material balance. We're going to carry out component balance. Carry out the overall material balance and the component balance. So the first one, which is the overall material balance, is simply means we are more concerned with compound, the individual composition, which is A, B, and C. We are more concerned with it. But for component balance, it means the individual makeup of this of B, C, and A. That's why you see A is having ethanol, methanol, and water. B is also having ethanol, methanol, and water, similarly to C. So that is component balance, material balance. So remember our equation is input is equal to output. And input is equal to output. So now let's look at this diagram and then bring out our inputs, the stream that is going in and the stream going out to one side. So all input should be one side, all output should be the other side. So A is going in, A is equal to output B plus C. B red is equal to B. B is 60, so 60 plus C. 60 plus C. So C is equal to 100 minus 60, which is equal to 40. So we know the mass of C to be 40 kilograms. So for every 100 kilogram of A going into the separator, 60 kilogram of B is produced. At the same time, 40 kilogram of C is also produced for every 1 hour. Now we are done with the overall material. To do is to carry out the component balance. So we have to carry out the component balance, and this component balance, the individual makeup of A, B, and C: ethanol, methanol, and water. So you have to carry out the component balance for ethanol, carry out the component balance for methanol, carry out the component balance for H2O. So for ethanol, to carry out the component balance for ethanol, still using our general material balance equation, which is input is equal to output. At the end of the day, we had this equation, we call it equation 1. A is equal to B plus C. We call it equation 1. So A, what's based using only ethanol. Ethanol. So ethanol in A is equal to ethanol in B plus ethanol in C. So what is the composition of ethanol in A? From the diagram, we say that ethanol is having 50% in A. Methanol is having 10% in A. H2O is having 40% in A. For B, ethanol is 80%, while for C, we are asked to find for C. So all you need to do is substitute it here. 50%, this is talking about the mass percent or weight percent, mass percent. You can express this in mass fraction. All you need to do is to divide it by 100. 50 divided by 100 is equal to 0.5. This is the mass fraction, but this is the mass percent. So we are going to make the mass fraction. So ethanol in A, we said is 50%. 50 divided by 100 is 0.5. 0.5 of A, and A is 100. Is equal to ethanol in B is 80%. So 80 divided by 100 is 0.8, multiplied by B, which is 60, plus ethanol. We don't know the composition of ethanol in C, so we just put ethanol. But we know the mass of C, which is 40, multiplied by 40. So multiply, collect like terms, and divide. So 0.5 minus 48 is equal to ethanol 40. So you subtract and you divide through. So ethanol becomes 2 divided by 40, which is equal to 0.05. So this is the mass fraction of ethanol, is the mass fraction of ethanol in C. So we can put 0.05. Now this is the mass fraction. To convert it to mass percent, all we need to do is to multiply by 100. So this becomes 5%. So ethanol becomes 5%. Methanol, all you need to do, still using our equation 1, A is equals to B plus C. This is the methanol of B plus the methanol of C. So methanol of A is 1000 is 0.1 multiplied by the mass of A, which is 100, is equal to the methanol of B, which is 15%, divided by 100, which is 0.15, multiplied by the mass of B, which is 60, which is 40. Multiply, subtract, and divide. So this becomes 10 equal to T. So this collect like terms, methanol becomes 10 minus 9 divided by 40. 10 minus 9 is 1 divided by 4, 0.025. So this is the mass fraction, 0.025. To make it the mass percent, all you need to do is multiply by 100. So this becomes 0.5%. Now it's important to know that when you can go through the individual percentage. If you sum it up, it should give you 100. It must give you 100. When you sum it up, it must give you 100. Or if you're dealing with mass fraction, when you sum all of it, it should give you 1. So the last one, which is water, component balance for water, we can say H2O A is equals to H2O B and then H2O C. H2O, the composition of water in A is 40%. So I want to express in the fraction. So 40 divided by 100, which is 0.4, multiplied by the mass of A, which is 100, is equal to the composition of water in B, which is 5%. So 5 divided by 100 is 0.05, multiplied by the mass of B, which is 60, plus H2O, which is what we are asked to find, multiplied by the mass of C, which is 40. So 0.4 multiplied by 100, we're getting 40 is equal to 0.05 multiplied by 60, 0.05 multiplied 3, divide through. So this becomes H2O becomes 40 minus 3, this goes to the side, divide by this 40. So at the end, 37 divided by 40 is our H2O is equal to 0.925. So this is the mass fraction we want to express in percentage multiplied by 100 is equal to 92.5%. So this is the percentage composition of water. This is the percentage composition of ethanol. We can also check it to see if it's correct. And there's another method we can use to find this, the third kilogram per hour, and the individual composition of C. For ethanol, we got it to be 5%, methanol 2.5%, and H2O got it to be 92.5.
So this is how to carry out material balance from the separator. Thank you for watching.